fertilizer applications pursuant to various research projects based upon efficient water and nutrient usage. Sir has served as industry or student license for ASABE in California. Sir has research interests in controls and automation, unmanned aircraft systems, computer vision, robotics, remote and proximal sensing, and precision agriculture. Sir has 2 peer-reviewed publications and 3 peer-reviewed publications under review. Sir has departmental representative for QF Postdoc Association at University of Florida, departmental mentor for Indian Graduate Student Association at Texas, drone demonstration for visiting students from Mexico University, represented the Department of Biological and Agricultural Engineering at TAMU Drone Day, a social chair for BAE and Graduate Student Association, and Sir has technical skills in software, hardware, and MLDL models also. So pardon me if I spelled something wrong, but definitely we are lucky to have you, an eminent personality like you. You seems to be very experienced, and in these kind of things, you seems to be very skillful, sir. So we are definitely grateful to have you here. On the behalf of Team Just Agree and our participant, I invite you, sir. I welcome you, sir, on the podium, and please address our participants, sir.
Thank you very much for such a warm welcome and very elaborated introduction. And good evening to everyone. My name is Ajit Papu Yadav, and currently I'm a postdoc at the University of Florida. And I'll be presenting some of my works that I did during my PhD and my current research based here as a postdoc at University of Florida. So if you mind, I'm going to share my screen and the slides.
Yes, sir.
So please let me know if my screen is visible.
Visible, sir.
Thank you.
Sir, please keep it in. Yeah.
Yes, so today the topic for my presentation is artificial intelligence-based computer vision for rapid detection and classification of objects in agricultural situations. This is also happens to be the title actually of my PhD thesis, primarily because I'm going to walk you through 3 different projects where I'm going to show how AI can be used for different agricultural applications. So as you can see, the future of farm would look like mostly they will be implementing AI-based stuff. And the reason for that is like there is a big demand for increase of productivity. And with time, we also have some labor shortage in farming situations. And also from COVID pandemic, we came to know that in these kind of pandemic situations, there can be a serious productivity shortages because of health issues to the working populations, and especially like farmers, and also the entire supply chain can be disrupted, right? So similarly, for also the reason for that would be sustainable farming practices is also going to become a necessity in future, and also to preserve our food supply chain disruption. So smart farming technologies of future might they might implement from the production to the robotics, machinery equipment, to the precision agriculture side. And you can see the driving force behind all of these future farming areas is the artificial intelligence, which is the AI. On the right hand screen, you can see there are like autonomous tractor driven from developed by John Deere, and there are like autonomous milking robots. They can autonomously milk cows. And there are like autonomous harvesters, like tomato harvester. You can see it's a robotic tomato harvester. And there is a drone sprayer, like a spot sprayer drone. You can see that was kind of developed as part of my PhD work at Texas A&M University. And the lower bottom screen that you see is just a conceptual thing about like how different technologies can integrate and collectively work together for smart farming practices. And you can see here, like in the robotics side, it can be applied to UAS-based to autonomous harvesting systems to the irrigation management. And on the precision agriculture side, we can use it for different, like for soil salinity map to yield map to precision planting to precision spraying. So AI is a growing field, and it is going to continue to grow. That is what has been expected. As you can see, a lot of publications based on the database of Web of Science. There were more than 10,000 articles that were published in by 2020. Actually, in 2020, that more than they use the term artificial intelligence. Similarly, machine learning and deep learning are like widely being used as the keywords in a lot of publications, research publications coming that they are using this keyword. So this actually shows a growing trend. All these three graphs that you see, they are like exponentially growing, and they all indicate that AI is going to continuously grow. The market value for AI worldwide is including all the disciplines is more than $3,000 billion by 2026. By 2024, and similarly AI in agriculture is going to be more than $4 billion simply for agriculture. When it comes to India, AI including all the aspects, it's going to be more than 7.8 billion by 2025. So that's the market value for AI based technologies. So you can see that AI can be used in wide range of technologies. They can not only be used in agriculture, but medicine, business, defense, surveillance. But when it comes to agriculture, as I already mentioned in my previous slide, it can be used in automation, plant and weed detection, to decision making, soil management, and disease and pest detection. So as I told, like AI has been there for a while. Right now, there are people that they claim that we are going through the fifth revolution of AI technology. And the fifth revolution of AI technology is focused on the automation and the robotics aspect of it. So that's exactly what we are going through right now. So there are different algorithms that are used. AI makes use, and some of them are computer vision based applications. And there are a lot of algorithms for computer vision. So computer vision, as we all know, is simply making the computer to see like the human beings can see and make decisions, right? So there are like different machine learning and deep learning algorithms that enable the AI-based computer vision algorithm. And out of them, I'm going to walk you through the applications of YELLOW V3, which basically stands for You Only Look Once. And YELLOW V3, YELLOW V5, and VGG16 is a visual geometry group 16 and support vector machine. So these are the algorithms that I used and for my projects, which I'm going to present today. And these algorithms make basically your computer to see and make the decisions just like human beings do. And I'm just keep showing here an example of a couple of published papers in which like they can be used for detecting, let's say, some tomato disease, which is called tomato early blight disease. And also it can be used for image classification, like if you have images of leaves of citrus leaves which have some black spot or canker disease, so you can train your AI-based algorithm to do some classification for you. So I'll walk you through project number one. Project number one is basically detecting volunteer cotton plant detection. So this problem may not be in India in particular. It is a problem that actually faced by United States and particularly in Texas. In South Texas, the climatic condition is kind of subtropical, so the cotton plants can grow year round, which basically means even if there is a rotation crops in the winter time, like let's say there was cotton plant planted in the previous season, and now they have corn or sorghum plants. So what happens? There are some leftover seeds in the field, and they start growing up. Whereas from Mexico, there is this pest called boll weevil pest. They migrate and they start these plants can host this boll weevil pest. And they can become danger because if they can rapidly spread and damage the future, let's say, season of the cotton plants. So in Texas, there is a program that's to control this pest infestation, reinfestation. So what they have to do is like they send people to find they cannot go inside the middle of the field. So they just scout on the side of the roads where there are rotation crops. So if they see some cotton plants growing on the side of the roads, they try to manually pull it or they spray it and they just try to kill it, get rid of those plants, right? But they don't, it's very challenging for people to go in the middle of the farm to find these individual cotton plants, right? Volunteer cotton plant. So what they do is they try to spray the entire field with chemicals. First, they spray with herbicide. If they don't get killed, then they spray with pesticides so that at least this pest will, if they are on the cotton plants, they can get killed. But there is a lot of wastage because they have to spray the entire farm because they don't know where these plants are. So what I did, we can use the computer vision algorithm to actually survey the entire field and find these, specifically locate these individual cotton plants. And then we can send a drone that can go and spot spray only these locations. So that way we can save a lot of time. We can also detect these individual plants that are cotton plants that grow in the middle of field, cornfields or the sorghum field, and then we can only spray where it is required to spray instead of spraying the entire field. So you are like also becoming like more like trying to save the environment, and also you are trying to save some chemical costs for the stakeholders or growers or farmers. So there are like benefits related to that. So we developed this like customized this drone by Helio AG1110. So it's basically a sprayer drone that was originally designed, but we attached some computing platform on board and some camera on it to do the surveying and use some what you call the computer vision algorithm to detect those cotton plants in growing in the middle of the cornfield. And then we can send the spot spray drone to only spot spray those locations that where it is supposed to spot spray. So this is the workflow chart that I will not go very much in detail, but I will just briefly explain because it can be seen in this paper. It's a preprint currently under review that we can go ahead and find the details of this. But what we did basically with this survey, so we surveyed it from a higher elevation, and we had 5-band multispectral camera by Microsense Red Edge MX camera. So it has 5 bands, red, green, blue, and near infrared and red edge bands. So as you can see, we have 5 different colored images. So these are from the 5 channels, and we did some image pre-processing called gamma correction to get the closer perspective. So we get this kind of images. It's a bigger size. Then we had to augment because we had only few images where there were cotton plants. So we had to augment using this label image software tool, and we had to get some annotated images, almost like 521. So there were cotton plants inside this, and we trained the computer vision algorithm called Yellow V5 on a Google Colab Pro platform. And then we split the training and the test validation and test images to find some matrices. And this is how we got the detection. So once we get detected, we need to find the GPS coordinates of this. So we found the GPS coordinates by extracting and doing some processing again. And once we get the GPS coordinates, then we need to send the drone to just go there and spot spray them. So our model performed like this is the range of accuracy from 78% to almost 98% accuracy. Correctly, it detected. Now these values are coming from a different growth phase. So we did like experiment, let's say in the early growth of the corn at V3 stage, and also at V6 stage, and also at the VT, the tasseling stage, growth stage of corn plants. Because as the corn plants will keep becoming larger, we wanted to test how the model performs well, right? So what we found as V6 stage, we got almost like 98% detection accuracy with some 2% of error. So as I told you, we did some at 3 different growth stages of the corn plant from V3, V6 to VT. We tried to find the accuracy, and what we found was that during the V6 stage, we found the highest accuracy. And the reason what we are assuming is because during this time, what happened was the corn was not even like very much bigger, but the cotton plants kind of became slightly bigger, which probably helped in the detection accuracy to be slightly higher. Wherever in the VT stage, what happens was the corns are very large, right? So they are like really big, and the cotton plant probably did not grow enough, and they were covered by the canopy of the corn plants, and we missed a lot of the detection. So the accuracy dropped kind of significantly. So I'm going to show you a demo of how the real-time detection will look like. So I'm just going to play the video. So what you are seeing over here is like we created an image in a real time, like we stack them together to create like a real-time imaging, and then we run our trained model. So what you are seeing in those red boxes, they are the model is detecting those volunteer cotton plants with some how confident the model is with some confidence score. And you can see in the blue text, they are the central coordinates of the bounding boxes. But these coordinates are based on pixel. We need to convert them on GPS. Then only we can send the drone exactly where to go and spot spray them. And this is after, so the previous video you saw was deployed on a laptop based GPU. Now, if you remember, we had a computing platform mounted on the drone. So that is where we needed to deploy it. And when we deployed it, so you can see, so there are like bunch of cotton plants you can see, and they are being detected. And there are some corns. So the corns are not, the corns are called corn, and the cotton plants are called cotton. So it mostly detects all of, I won't say all of them, but a lot of them, most of them, and some of them it gets missed also, right? So because of inaccuracy in the model. And this was deployed on the Jetson TX2. So the computing platform that was deployed on the drone was the NVIDIA Jetson TX2 GPU. And as I told you, let's say you have a 30 or 40 cotton plants randomly detected in this field, right? So you need to also design, because the drone has a limited battery capacity. So you cannot send the drone like randomly to, let's say, location 1, 2, 3, 4. You need to find an algorithm or way to send the drone in a very optimal flight path, so you can save the battery. So the routing, so basically it's optimization of the routing. Now you send the drone, you did the surveying, you found those cotton plants. Now you need to go any spot spray, but you need to find a way, the best routing, so that it can go in the most optimal flight path to spot spray them. So we use ant colony optimization algorithm to find the best routing. And that's when this is how we did the simulation on a, what you call, map proxy software. And before actually sending the drone to those spot spray, we needed to use ant colony optimization algorithm to optimize the flight path and then send the drone. So we use map proxy and mission planner software both for, so that this screen is for map proxy ground control station software, and the other one in the background you are seeing is based on mission planner ground control software. So what you are seeing is a drone went from the home to the first location, then it went to another location, then it goes to the third location, and that is how it follows its optimal flight path. So as you see, it's making its path to go to another location where there is another cotton plant that is detected to do the spot spraying application. So in the lab condition, we also tested the spot spray application. So what you are seeing here, so as you say, when you did the surveying, we use 5-band camera, and when we use spot spraying, we use another RGB camera. And now in the spraying flight, we need to send the drone at a lower elevation. And this is the nozzle that we used to only precisely spot spray that particular spray. So in lab condition, when it detects cell phone, as thinking that is a whole interior cotton plant, it just turns on the nozzle and then it is spot sprays that. And we have done the field test later on, which is not available in this. And we are also going to do a future demonstration here at University of Florida. And once that is available, it will be made in our publication too. So as that was project number 1. So we also did another project, which is for plastic contamination in cotton. So we might know that when cotton plants are planted, their fiber quality is really matters, and their marketable value depends on how clean those cotton fibers are, right? But because round cotton modules, they are used, when they are getting harvested by some machinery system, those plastic contaminants, they get entrapped in the cotton fiber, and they reduce the marketable value for the cotton. So in terms of United States, annually, there is a $750 million to the US cotton industry, just because of the plastic contamination. So the idea was, can we use some computer vision algorithm to detect those plastic contaminants that's in the field? So we did some field experiment by manually tying some plastic bags on the cotton fields, and then fly the drone, use the algorithm to detect the bags. So I'm just showing here a source of cotton. So what happens a lot of the time, plastic bags that are sometimes they are on the side of the roads, or they get carried away when there is a wind, and they go in the cotton field, and they get trapped on the cotton plants. So what happens is, if there are like a lot of them, it's very difficult to manually send somebody to go and find those plastic bags that are like trapped on the entangled on the cotton plants. So can we fly drone with some computer vision algorithm to detect those plastic bags and then send somebody only to those locations, just like we did spot spraying, to go to those locations, and maybe we can send ground-based robots to just go and pick those plastic bags, right? So that is one source of plastic contaminants getting into the cotton gene, and then eventually into the cotton fiber. And some of them come from the like yellow covering they also use in the round cotton modules when the cottons are harvested. These plastic bags, they get torn and they get also trapped, and they can also end up in cotton gins. So in our experiment, we, as I mentioned, we tied like two color of bags, white color bags and the brown color bags. And then we flew our drone, and we used like at 60 feet or 18.3 meter from the ground. And we did use our computer vision algorithm to detect them. Our idea was also to test which color of bags get detected at a higher accuracy. Like, can we detect brown color bag at higher accuracy or white color bag? So this is the workflow chart, as I told you. So we collected the images, and this is how the big, large size images look like. We needed to split into smaller size images, and then again train the yellow V5 model. And then we need to split into training, validation, and testing data set. And once we did that, this is our result that we got, that we found what, as I told you, we also needed to test if brown color bags get detected at higher accuracy or the white. It was found that there was a significantly white color bags were detected at a higher accuracy than the brown color bags, as expected. So it's kind of believable result. And since yellow V5 also comes in 4 different, let's say, varieties, depending on the size of the model, we also did a test of like which model performs the best if there is any significant difference. So in terms of average precision, what we found, yes, there was significant difference between the small, medium, large, and the extra large models, whereas the medium model worked equally good for both brown and white color bags. So this is how our result looks. So in totality, what we can say that it doesn't really matter much if you choose yellow V5M model, you can still, or yellow V5 extra large model, you should still be able to detect your white and brown color bags with similar accuracy. This is a detection result, as you can see. In the BB means basically brown bags, and WB means white bags. And these are the confidence scores that you can see that the model thinks that. So this is how we detected the white and the brown color bags using some computer vision based algorithm. So in our third project, which is part of my postdoc project here at University of Florida, because in Florida, citrus is a major crop. So in Texas, those projects you saw, they were from Texas. In Texas, cotton is the major crop, whereas in Florida, citrus, and in citrus, there are like oranges, tangerines, grapefruit. So this is like ruby red grapefruit, as you can see. What happens is there is a problem. There are a bunch of disease conditions that happen in this kind of citrus. As you can see, there is a black spot, and there's a greasy spot, melanose, and normal, and the wind scar. So what they cause also reduce the marketable value. So the goal is, can we use computer vision algorithm to detect them early before they become spread out a large, so that can we do some treatment or spray applications using computer vision algorithms, so that we can save the damage that will happen eventually to the citrus fruits. So the goal is to classify, to train some AI-based algorithm to tell, okay, this belongs to this citrus fruit has black spot disease or melanose disease, or they don't have any disease. So we used a hyperspectral imaging system. So we collected some of the fruit samples, and actually we did for like 7 different conditions, as you can see, as you saw, more than what you saw in the original picture. And there are like marketable canker, greasy spot, and we have this paper just got accepted like 2 weeks ago. So it will be published very soon, hopefully before the end of the year, in Frontiers of Plant Science. So you can see, so the results will be available there more in detail. But we use hyperspectral imaging system with a 92 spectral bands, and then we try to train our algorithm for detecting them. So we don't want to use that all the 92 bands. So what we did, we tried to do some dimension reduction using principal component analysis to find the 5 most contributing bands. So what we found was these are the wavelengths of the 5 most contributing bands, band 1, 2, 3, 4, 5. And these 5 bands were eventually used to train our VGG16 like a deep learning model. So VGG16 is a deep learning convolution neural network architecture that can be used for both feature extraction and classification. So in our case, we used it as a feature extraction first, and then softmax was used as a classifier. In the last layer is a softmax layer that you can see over here that is used for classification. So we give the input, it passes through different layers, and eventually it extracts the features, and then we do some classification. So this is the result that we got after training the model. And you can, once the paper gets published, the detailed things will be available there. But what I can tell you here is that you see when we train the model, we see the training and the loss graphs over here. So, and this is the accuracy graph. And this is a rock curve. So basically the area under this. So what these values are telling you, basically between all these 7 classes, the lower value means it has the least discriminant. So it is detected with the least accuracy. So what we found was the MD class, which was detected with a very like a perfect detection accuracy, or the classification accuracy, I would say. And the wind scar and the scab were detected with a slight kind of the lowest accuracy you can see over here. And this is a confusion matrix that tells you like how many were misclassified. So let's say for this class 0, which is a normal, 190 were correctly classified, whereas 1 was misclassified to be as another class, and 3 of them were misclassified as class 2. This is also where class 0, 1, 2, 3, 4, 5, 6, 7. They go in the order. So class 0 basically means the canker, greasy spot is class 1, and henceforth. So this is how you can see how the model's performance was on this one. So the key takeaway is like, yes, we can use AI-based computer vision algorithms to solve many of the agricultural problems that's faced by the world today. And especially the equipments like robots, drones, and other agricultural machinery equipment, they can make the use of AI-based algorithms to solve many problems that or challenges that the worldwide agriculture faces. For example, precision spraying, automated harvesting, precision spraying, I already demonstrated about that. It can be used for automated harvesting, efficient water and nutrient management, pest management, I already showed you this, and yield estimates, and bunch of other things. And it looks like India is the 3rd largest country in terms of like a startup, AI-based startup in agriculture. I think it was almost valued at $4 billion of market, like just for I think by 2026, that's what the prediction says. So I would like to thank like all the collaborators and all the co-authors that were involved, including all these people that you see. And also I would like to mention Dr. Gopal Sindhya, who connected me with the Just Agricultural team, and Dr. Utkarsa Gaurav has been really helpful in trying to organize and invite for this. So if you have any questions regarding any of this presentation, please feel free to email me. And you can also connect me on my Twitter. And I would like to thank all my collaborators, including from Texas A&M, to the Cotton Engineering Program, to the University of Florida, the USDA APHIS, and thanks to Just Agriculture for inviting me to present some of my work. I'll be happy to take questions.
Thank you, sir. It was indeed a very insightful session, and you have presented your research work and the findings here. It was commendable, and we have a mixed audience here. Like we have students, we have farmers, we have agripreneurs, and some of the students who are in graduation, they just want to know about the postdoc, because they have heard up to PhD only. So they just want to know that what is a postdoc doctorate, and how we can apply for this, what is the eligibility criteria, and everything about that.
Sure, I'll be happy to answer that. So basically, after you do your PhD, so there are 2 options. Normally, people like to go in the job market. Either you choose to go into industry based R&D field, or you want to go into academia, like you want to become a lecturer, professor, these kind of positions, right? So postdoc is mostly targeted like towards the students who are looking to build their career in academia, and it's like a training before you get to become a faculty. So it's like enhancing your research work that you did in your PhD, with some diversification. So as I told you, I did most of my PhD work in cotton, but when at postdoc, I'm trying to diversify my work, my similar knowledge with some additional crops or different kind of learning some more areas. So in this, I'm also teaching some classes and I'll be teaching in future. So it kind of uh, helps the people, the postdoc, to develop all the skills that you did not develop during your PhD work to become a faculty, mostly, primarily. However, postdocs also can go into industries like research-based positions that are available. A lot of industries these days, they hire postdocs also. So that is but primarily it is targeted towards the academic-based jobs. If you are looking yourself as a future faculty members, then postdoc helps you to enhance some of the skills that you lacked during your PhD. Secondly, to answer like what are the application criteria, it's simple. Like you have to when you are about to finish your PhD, the ideal time is you start trying to look for different professors, lab positions, like in your area, whatever research work you do, your area of interest. If there are postdoc positions open in their website, most of the time in their website, they do the posting, or even in the social media of the professors, they post that they have a postdoc position opening. So the way to apply for is this: you just send an email. If you see those kind of opening, you just send them email to those professors who are looking for postdoc, and you forward, and then they will tell you to send your CV or send some of your publication draft, and they decide based on that.
Okay, sir. Sir, another query which I have got is, how do you see the future of artificial intelligence in precision farming in India?
Yeah, so in terms of India also, I see there is a huge potential, as I already mentioned in my last slide. Like there is a lot of AI-based ag tech companies, like it's like really growing faster, and they are getting a lot of funding, not only from Indian government or Indian sectors, but also from outside sectors. So I see there is a big potential, especially for the small scale farming. Like as I mentioned, this drone-based spraying can be very much beneficial. Like let's say you have to even if you find a weed detection, instead of spraying the entire field, you can simply locate where precisely those weeds are, and you can do spot spray. And John Deere has like those kind of see and spray technology that they have developed. So it only sprays where there are weeds instead of spraying the entire field. But that tractor might not be very much that is meant for large scale farming like the United States. In India, where their farming is done in a smaller scale, I think spot spray drone system might be very beneficial. So precision farming has a huge what you call the a future, and to enable that, AI needs, it's like a requirement, right? With AI based algorithm, you can do precision farming more efficiently. So I see there is a big future growth.
Yes, sir. Sir, some of the participants, they just want to interact with you. So, is it possible that they can directly interact with you?
Yes, of course. I'll be happy to do that.
Yeah, sir. Okay.
So can I stop share the screen, or sir, do you want me to continue sharing the screen?
Yeah, sir, you can stop sharing the screen.
Okay.
I have participants can raise their hand if they want to interact with sir.
Yes.
Sir, till now I have got another question from the participants, which is of their interest, like on the interest of Indian students and farmers. In India, people are going for organic farming. They are just the government is also promoting organic farming and natural farming, and we are talking about precision farming and the artificial intelligence, that it has a bright future in India. So how do you see the both scenarios? Like, will they coexist, like the organic and natural farming, and with the precision farming, how they will coexist in India?
Yeah, that is a very good question. I mean, precision farming is meant to avoid as much chemicals as you can save and make things more efficient, right? So even like in terms of when we talk about organic farming, your goal is basically not to use this kind of chemicals most of the time. When it comes to, let's say, it has been found that if you want to really compete in the market like India, where there is a big demand and very less supply, so I'm not sure like how much sustainable organic farming might be in practice. But if you really want to have some food security, then you have to really use technologies that can enhance productivity. So that may not necessarily come from organic farming. However, I would not like to make any strict comment or argument on that, because it's kind of outside my research area. But to my knowledge, what I see, like they can coexist depending on different scenarios. But definitely precision farming and new based technologies, they can only help in that. Because let's say you want to still do precision harvesting, even if you have organic farming, you can still use robotic harvesters, right? And they can definitely what do you call, help even organic practices in those kind of areas.
Yes, sir. So it is quite a controversial statement in India. Even everybody is like they just don't want to make any statement on this. Like this is very controversial nowadays.
Yes.
So another question which I just got from the participants is how like you have talked about the plastic contaminants in the food. So can you just elaborate about that, like how microplastic is affecting our food system and our health?
Right, that's good question. And my actually project was in the cotton, like how does plastic. So what happens is there are like well, let's say there is like a big wind blowing, right? So those plastic bags, they usually get carried away and they get entrapped or entangled on those cotton plants, and they end up at the cotton gin. So the cotton fiber, so here when you are using machines to do the harvesting, those bags, they get mixed in the cotton fiber and they reduce the quality of the cotton fiber, and becomes challenging because when they in the machines, they get stuck at different places like in the machinery system, and sometimes the machine gets damaged, and a lot of the time, even if the machine allows you to pass it, the quality of the cotton fiber gets affected. So the cottons are graded, and their grading becomes lower, and then the growers have to pay, they get less pricing for their cotton, the value of the cotton. So this is challenging. So what we can use, new technology, we can use AI based stuff. So before you do harvest, what you can do, you go and fly your drone, you find where the bags are, and you can send the people exactly with a GPS based machine to go to those locations of the bags and then pick up those bags. Or you can also send like our future project that we are planning to do is like use some robots, like autonomous robots. They can go there and they can pick up the bags autonomously. So you fly the drone, you get those bags location, and you send the drone to take that. So in food industry also there might be contaminants, but I'm not aware of the contaminants exactly in the food sector. So if I have some additional knowledge, I can share more paper articles focus on the food side of it, like plastic contaminants towards the food side. Yes.
Thank you, sir. Actually, there was a report earlier in this year that microplastic was found in the food and in the human system. So that's why I think this question has arisen. So thank you, sir. Thank you for answering it honestly. So thank you so much, sir. And we are done with the question. So in case if we get any other question from the participants, we'll convey the questions to you through mail.
Thank you. Of course.
Thank you, sir. Thank you for such an insightful session. It
Thank
was
you so
indeed a very informative session for me as well. Thank you,
Thank
sir.
you. I'm glad that some of my work I could present here, and I would like to thank the whole team of Just Group and also Dr. Sinde for connecting me with all of you.
Thank you, sir. So now moving ahead, I would like to introduce our next guest speaker, Dr. Gopal Shinde. So Dr. Gopal Shinde is the principal investigator of Nahep DFSR RDA VNMKV Center College of Agriculture, Engineering and Technology, Vasant Rao Nayak, Marathwada Agriculture University. So sir has done bachelor's in engineering from Baba Saheb Ambedkar Marathwada University, MBA in marketing from Swami Ramanand Tirth Marathwada University, and MTech in Mechanical Engineering from Indian Institute of Technology, Kharagpur. So sir has done a PhD in mechanical from Swami Ramanand Tirth Marathwada University. So sir has worked in various capacities if we talk about academic experience. So sir has served as assistant professor and PG coordinator in mechanical engineering, MGM institution, and visiting faculty in SRTM University, India for MBA course, adjunct faculty in computer science, MGM institution in India. And sir has also served as visiting faculty in agricultural engineering college, VNMA University, Prabhani. So sir has also served as director and principal of SHJ Polytechnic College, Mumbai, and assistant professor of mechanical engineering, Department of Farm Machinery and Power Engineering, College of Agriculture Engineering, VNMKB, Parbhani. So now coming to the sir's publications, sir has numerous publication in various reputed national and international journals, and sir has conducted and attended various seminars and the trainings and workshops. So the list is very long. I can't mention all of them here because of the shortage of time. And sir has been the editorial board member of various reputed journals, like sir is associate editor of mechanical engineering or bioinfo publications, international editorial board member of International Journal of Agriculture and Biological Engineering, editorial board member of International Journal of Material Science and Engineering, and sir is in the scientific committee of editorial review board member of Engineering and Physical Sciences, World Academy of Science, Engineering and Technology, and also editorial board member of Indian Journal of Advances in Computer Sciences and Technology. And also sir is reviewer in various reputed national and international journals, which includes International Journal of Agriculture and Biological Engineering, International Conference on, and sir was the reviewer in International Conference of Food and Agriculture Sciences in Malaysia, and International Journal of Agricultural Sciences Research, and many more. And furthermore, sir is the member of various national and international prestigious societies and the organizations, which include International Association of Engineers in Hong Kong, American Society of Agriculture and Biological Engineers, and Asia Pacific Chemical, Biological, Environmental Engineering Society, and International Society of Precision Agriculture, USA, American Society of Mechanical Engineers, and Association of Agriculture Engineering, Bangkok, and many more. The list is also long in this case also. So sir, your biodata, your CV shows us that you are such an eminent personality. You have done so much work in your field, and we are so honored to have you here on board. So without wasting much time, I would like to invite you to deliver your insightful talk to our participants and enlighten them with your knowledge and your expertise. Thank you, sir, and over to you. Sir, you are on mute. Sir, kindly unmute yourself.
Can you make my another device unmute, which is on the laptop?
Sir, can you please tell us the username with which you have joined?
Gopal Shinde. Gopal Shinde.
Okay, sir. Okay, sir. Our technical team will do it for sure.
Yeah, sure.
Thank you.
Yes, sir. You can.
Thank you, Himani, for being with this. Am I audible properly?
Yes, sir. You are properly audible.
Yeah. So I must thank first of all Just Agriculture.
Sir, actually, you have joined from two devices, so there is a problem of echo. Sir, now this is on mute.
Hello, am I audible?
Yeah, sir. Now it's fine.
Okay. So I'm just now sharing my screen.
Sure, sir.
I think now it's clear.
Yes, sir. It's visible.
Okay. So for this prestigious and glorious event. First of all, I thanks to the Just Agriculture team, especially Badwalji and Utkarsha and Himani, who are always getting persuasion to have kinds of a different state of art of the world glorious spectrum, where the digitization, digital agriculture technologies, and the all magical new things are happening. So being with all of this huge experience from India to various countries, and now I'm in US. So for this Just Agriculture, the event that has been organized, it's a really prestigious and good to the career of these all researcher students, entrepreneurs, farmers, and then all the professor faculties who are doing their work in the new era. Today, I'm going to present the smart farming technologies by robots, drones, AGVs in precision agriculture. This theme is basically we are aiming to make this explore in all over India as one of the eminent prestigious project by Indian Council of Agriculture Research, Government of India, and especially Maharashtra Council of Agriculture Research and our Vasantrao Naik Marathwada Agriculture University as well. So the project title, it is specifically aiming to make the digital farming solutions for enhancing productivity by the drones, robots, AGVs as of the new attraction to the new researcher generation who are aiming to make this area captured for the entire agricultural operations on the tip of the finger. So they want to just make this all the specific areas that we have already discussed, and I'm really thankful to Professor Pappu Yadav, who have on 11th hour accepted my this kind of message from Just Agriculture, and he delivered also in this morning, early morning, I should say. So this presentation is going to make you all aware of the indigenous technology as well as what are the things are happening in India, and in fact now USA, I should say, because making of those all progress and updates all the time, I should be making the new things to be as a part of arrival when everyone is interested to know what is the new thing. So we are just tabulating these all things into the three words, and those all made as a division in our center of excellence, that is agri boat, agri drone, agri AGV. So for these three divisions, as a part of involvement, the professors from Vasantrao Naik Marathwada Agriculture University, they are going to participate by use of these four portfolios, and in fact fifth portfolio that we are all together going to get involved as a part of outcome of this center. So climate decision based knowledge support center, that is called CDKS, seedling processing nursery automation called SSPN, smart portable machinery center, then food processing automation center, and instrumentation cell. The name title itself is, you can see that the climate based, all the dynamic parameters which are going to make this control over the operations, field operations by use of the automated technologies. See, automation is with the help of mechatronics applications such as mechanical component, electronics components, and computing softwares. As of the advanced state of art, the present is I'm learning here machine learning language, deep learning, by use of the different types of softwares. We are using Python software, we are using Visual Basic, we are using R programming, ROS programming, and so many kinds of software tools which are freely available as open source for all of you participants to start initiating at your home and get the things learn of how these all software programming can be used. These are software programming looks like the text script which is to be designed by means of the tabulated terms, that is tabulated commands. So you need to write an algorithm, you need to get the language which can be understood by the machine by use of different softwares. So those all things are coming up in the different area of this which is we are finding the new. So this project is going to divide into these 3 divisions and 5 portfolios, as well as the name that will be self-understanding. In agribots, the different types of robots as nowadays are used in the world. Wherever the developed countries they are using, they are just trying to get up this robots to modify to in the state of art, which can be commercialized further. So before that, the all kinds of technical ingredients which are need to be understood by every agricultural researcher, scientist, and those who are especially newer to the field of software, they can easily go on Google search engine. They can use OLab for their understanding to make this all software commands, and then different kinds of software tools, how do we can apply them for running the machines to understand, recognize, and get decision tool that get decisions as a decision tool for the farmers who can apply for the different kinds of outcomes. Here we have Jacqueline Husky robot, and that is in our Nahep center. We already explored, shown this online whenever there was a workshop, and we are also having a 3D printer machine in which a different components that we are customizing as of like sometimes we need some special types of components and that is not available in the market. So you can go for designing any component and create your own machine, also create your own software, a digital tool which is convenient for the farming operation, and that will serve the purpose to get outcome as of like following applications. Sometimes you require the robots for harvesting operations, weeding operations, sowing operations, grafting operations, detection, pest detection and control operations. Sometimes you need to go for identifying how many number of fruits are there in the field, and as well also the plant can be identified how many number of plants. So IoT tools is that the area where now farmers can be easily become a closer friend to the digital technologies. If they know what are the number of plants in their field by use of the mobile, so they will be get attracted. If they know how many number of fruits are there in their field which are located to different plants, so they will be get definitely attracted. In fact, the biomass and yield prediction is of kind of keen attentions of the farmers who are looking for their target. By materializing all those efforts, they definitely going to see how much of the yield, how much of the outcome which is benefiting to them. So look, this kind of in USA. I'm very happy to share these videos right now, which I have experienced in the blueberry, blackberry, the different field plots in which the Husky robots, in which the different kinds of sensors and their software programmings that are going to expedite the data, which will be helping us to know what are the exact situations in the field. Maybe it is like you may interested to know what is the plant health condition. It may be you like to know what are the different stages in the plant when you are going to look at them before sowing, after sowing, and then maintaining health culture, and at the end the yield by post harvesting operations. So these all the activities that we are going to do. Here you will see the the operation which are mounted here can be a wired or wireless pendant to control the robot as of the monitoring device in the field, or you can have a wireless we can have a wireless even robots wireless pendant which will be going to help us in making the different kinds of health condition monitoring. So these are the activities, as Professor Yadav has mentioned, the different kinds of robot applications nowadays in citrus and identification of the different diseases. Actually, how these all prediction points looks at the different levels is very much good attraction for this, and I feel this is going to make you all involved in the field of agriculture robots to be as an applicant device. Some of those who are interested can put their business also into making these robotic applications as a custom hiring service center. Then next is the agri drone, in which different types of drones are nowadays lakhs of companies entered into the market, and every company has their new attraction. However, in United States of America, we have visited the different drone manufacturers, and we have seen they have a limited number of drones companies where they are permitted by the United States of America government for making the manufacturing, and as well the operational needs that are going to be attract the agricultural society. They are remote sensing, then spraying operations, and the different you can say field related, those subsequent applications which are relating to the field automation system. So the different types of drones are available at Nahep Center, and our team is exercising different kinds of the drone applications, and the trainings which are specially needed by all of the participants. Those trainings which are going to start by us in the forthcoming couple of weeks, maybe in the next month or maybe in the next year as well. You can say January month onwards, we are going to start the trainings, and the attraction of the young researcher should be to know how the drones are, how they are constructed, how they are electronically skeleton, and to make the new drone is the attraction. So that is why I am here to work with the team of NASA under guidance of Professor Aditya Singh. I am doing here work with a drone club which is constituted by the undergraduate, postgraduate, and researcher students, and they are going to, I mean, we are going to participate with them, and we are at the stage right now. After passing 2 months, we have just constructed one drone which is which can be used for the remote sensing. So using these things which are in the field as we required, we must have to know what are the different components and their specifications in the drone, and how these all components are made of, which kind of material, or maybe the kinds of those all technical aspects. If you know well, then you can be a very good engineer to operate, or maybe you can be a very good technician to operate this. So using this drone is a new challenge, and I will say the experience of this in the Florida field. This is a new kind of drone in which we can use a fuel engine based the energy, as well as we can use battery system. So if we use this dual energy system device, it will be helpful for us to customize and make an economic way. However, there are certain limitations. This is going to be a, you can say, challenge of making the new kinds of developments, and those all developments which are attracting us to make their application and get the different difficult operations in the field to be easier. So we are using hyperspectral camera, and this hyperspectral camera will be sensing the different kinds of images to use it for the biomass detection. So you can have a biomass prediction using this kind of a drone, where all these operations are very much essential, and we can have a survey, we can have a different predictions at the state of art when the crop is going to be reach at the final stage, and that is you are going to make the plan of harvesting as well, and also you can have the different quantum of those all which are predicted versus the actual field outcome that is you're going to get. So this is I'm just making one thing to add in this regard, as this is the new attraction to the new arrivals. So we must know that the automation system that you are using, mission planner, and that mission planner is a software where the drones can be mapped on Google Earth locations, and we can make a perfect trip of this drone to get excavate the data as of like which are we interested in, to find out the exact difficulties or to find out the exact field related problem. We are using different motors, as they are called brushless motors, brushless DC motor, and those brushless DC motor is a challenge before our country to make this manufacturing and get available to the Indian farmers or the operators, technical operators who can use it as like a vehicle, and it will be immediately also repaired or maintained whenever there is a accident or maybe a breakdown, failure, anything that comes around. Because to drive this device, you will have a challenge. If it fails, then that means you are going to lose out the big cost. So as far as the fail-safe mechanism and the technology that is coming up into the market, that whenever there is a failure in the drone, so you will have a safety measures to look at this as a mechanical damage, then it should be protected. So there are different types of drones, and those all drones can be used. Now we are coming to the next part, that is automated guided vehicle. Is of similar kind. That robot we see is a similar kind. The device that we works, this is in fact the small kinds of portable machineries that we are going to apply it in the field. We have designed a cotton picking machine, then mobile operated a sprayer, vegetable the sprayer machine, wherein there's all kinds of operations are get automated or semi-automated. You can have these all kinds of a design of those machine components in our CAD/CAM lab, and this computer-aided design, computer-aided manufacturing, and computer-aided engineering analysis kind of activities we are doing here by use of the ANSYS software. Then Python programming, we are using MATLAB, we are using different kinds of design analysis simulation softwares. We can go for designing different new drones also, as the students have started doing their work in our actual lab practices. So by graduate students, undergraduate students, postgraduate students, and doctoral students, those all are working at their state-of-art problem level, and they are getting also a training from the prestigious institutes, premier institutes of India, that is IIT Kharagpur and IIT Bombay. IIT Bombay and IIT Kharagpur, they are working with us as a knowledge partner. Now, I'm very much proud to say this facility platform from India that has been created by the help of the coordination and the permission of Government of India. So I must thank to Government of India, especially thanks to National Director Dr. R.C. Agrawal, Dr. National Coordinator Dr. Anuradha Agrawal, our special thanks and energetic person Dr. Indramani, who is Vice Chancellor of our university, who is recently joined from Indian Council of Agriculture Research. So these all trainings, we have a robot, and this robot gets grafting of these two different plants, brinjal plant or tomato plants. You can have a brinjato as a joint part in our robotic system. So making this all applications is attraction, and I'm feeling that if you are comfortable, you can join, and you can always plan to make the visit of our program. This will going to attract the newer arrivals which we are doing at our center level. So you'll see this is a new machine that we have designed, which was not earlier maybe presented. This is working on the this is working on mobile Android software tool. Any food expertise can go for making his own design and just get design of this template and just take out it from the 3D printer as a standard template. You can change as well. So 54 types of products you can create with the one single machine, which is not costlier, which is just at the cost of 90,000 rupees. So if you are using such a kind of advanced tools and the machines, you will going to get attract. Now here I saw the attraction towards the 3D food printer. So 3D food printer is the new attraction. You can have printing on the cake. You can have different the food products as outcome with the different dyes by using 3D 3-axis motion, food feeder mechanism, food gradients feeder mechanism. Thereby you can have your own product. The everything that comes and meets to as an outcome, that is a your the achievement of the project. So you are looking at the different aspects. So here you will find you have all kinds of mechatronics facility where students are feeling scared of knowledge. They can go and just learn it on the self-learning kit, how to this use construct the different types of electronic mechanism or electrical kinds of operations, or the different kinds of computing softwares, as well as the different kinds of IoT tools, or maybe any kind of sensors, how it works. So those things you can go and get it learned. You can use the cameras. There are different cameras. You can have attraction of different cameras, as I mentioned. You can see those cameras, how it works, and what is the purpose of those camera, and you can use it for your own problems as in the field. We can have this 3D printer for a student's new attraction. They can go for designing their own nozzle, and they can find out their the plant canopy related spraying pattern, which will be minimizing the wastage of the sprayer pesticide. And that sprayer pesticide, which is minimizing the wastage, is going to be account your economy of the farmer, economy of the state, or economy of the nation. And that is one of the attraction for us. So the students are attracted to create their own robotic arm. So you will find here the robotic arm has been created. Students are going to the field and taking their the drone operated images, which will narrate the exact problems in the field and get the solution out of it by use of the drones technology. The students can join the training programs as on the website, which we are always showing you. The present state, we have this cotton picker machine, which is working by on solar system, and this machine is going to again help the farmers, as the robot cannot be purchased, but this machine can be purchased at the cost of around maybe 70,000 to 80,000 rupees, and it works on self energy exploring cycle system, that is photovoltaic cell and the solar systems, which is charging farmers. And the female, they are collecting the cotton. Per day capacity is around 50 to 60 kg, or maybe at the most, if exceptional case, 70 to 80. This machine can work for the three woman operators, like 160 to 180 kg cotton you can collect. So I was just trying to make these new things as a part. You can see the cotton is picked up, and you will see the cotton of the quality which is coming up by use of this machine is the new attraction for the small marginal farmers, those who can offer the cost. As a new part, that the robot, how it should be, robot should pick up. Robot should pick up the robot should pick up the cotton, and that is a challenge. But before that, the challenge is you can say how this technology will work. So students, they are not aware of the electronics and mechatronics technology. So we made one collaboration, and we started working with this problem that a robot arm can pick up the cotton ball. So if it picks and sucks the cotton ball, that time it takes the response, immediate response to identify the cotton ball. But however, this is just at the beginning of the journey where we identified the cotton as well for the harvesting stage. We are aiming to make the robotic application for cotton related problem detection. This is another, you can say, AGV device here in which you can use the paper pot chain mechanism using the wireless or wired pendant. You can have a remote operative this device by use of the mechatronics kit and technology. So at the rate of only 1 minute, you can have 265 plants which are planted. So the specification are those all robotic arms, and then small kind of devices are designed by the students. They get it printed here in the printing machine and get learn of them how these all machines with those all technology can be useful to their knowledge. And once they get this device run by their system as a well, it's excellent, acceptable, that can be a patent. So getting a patent is a far difficult thing, is just fear of mind that it will take all those all efforts and lot of time is nowadays gone. Now you can just go for making your own design, get it, test it on in the software and print it out, and then test it in the field. If it runs well, then you can sue that as a patent of your claim, which is benefiting to the farming society. So this cycle is to have this patent cycle for the researcher students who needs their thesis to be value added, because the thesis that you're going to submit should be value added. If you don't award it by outcome with this kind of achievement, then they will not be said that as a researcher. They will just say as a formal degree holder. So we don't want to be a formal degree holder in this regard. So making this by the student is an attraction nowadays, and the students are also doing their own designs. You see these all the components and then parts are designed by our Nahep team, and the students that they're learning how to make this design and then print out. See here there are two components. You can see the design is made and then print out and then get tested into the field. In the field, you will get a learner by use of the sensors, how those all operational tools are useful to them. So those things which are going to attract in the different field operations, that the smart farming is nothing but the use of the sensors, use of the IoT tool, use of artificial intelligence, use of the brain to hand over it into the machine, which will operate, explore by their cell phone way. And this is the outcome. You see, students are getting their learning process, and they are putting this all information by adding the knowledge to make the tools in their thesis, and they're getting published of the papers. So paper publication is also attraction. You'll see all those spectroradiometer, multispectral images, they're taking it by hand. Now they will be taking it by robot. So this will be all together. They are exercising to get vegetation index. They are going to take different types of crop water requirement satisfaction index or scarcity of all those components, NPK in the soil sensor also, how those all the contentive information will maintain their health is the new attraction. So meeting all those dignitaries, personalities, Nobel rights, to have this kind of experience as of me, I am just feeling a very small person to get these all things collect, and maybe putting it to all of our participants as a feast for their future forecasted plans in their career. And this is definitely going to make a new attraction to develop the different kinds of the new technologies, and that is the attraction of every one of us. So use of the mission planner is a new thing for the participants who can get learn of. You'll see that brinjal and tomato, these two different plants, they are grafted and made brinjato. So you can find in somewhere in future that on one plant there will be a brinjal as well as the tomato. So I'm just making thanks to all of the Just Agriculture team, and this is going to be a glorious event which are very much kind of attraction. And I really congratulate to all the team members, especially Badwal ji, Utkarsha ji, Himaniji, and all other team members from our Parbhani center also, who are gathering and getting these all things to energize the Digital Farming Society of India. Thank you very much. And you can have a questions if you are having
Thank
any
you, sir.
discussion point with me.
Yes, sir. Yes, sir. Sure, sir. It was a very
I think
wonderful
I'm
session.
sorry to say, because I have taken 10 minutes more, I think, I suppose.
No
So
problem,
it was
sir. No
given 40
problem.
minutes for me. I have raised to 10 minutes more.
No problem. So it was very informative session for everybody, and I just hope that it goes it goes long more than 10 minutes. It's quite informative, sir, and we got to know about how your institute is working so on the robotics and drones, and it is very informative, and I hope that participants must have got the best knowledge from you, and they have queries about the topic also. They just want to know, like, if you permit me, I'll ask the questions on the behalf of participants. Yeah. So participants just want to know about the, like you have mentioned about the trainings. They just want to know, like, which kind of trainings VNMKV Prabhani is providing, like on drones or on the robots, like what are the programs and how they can apply, how they can get the information about that.
Yeah, well, this is for a sake of simplicity. First thing that I will say, I'm just going to share. I'm going to share this, portal address, nahep.vnmkv.org.in, and elearn, that is going to develop elearn.vnmkv.org.in, and we are also going to communicate it by use of Facebook, LinkedIn, all those linkages. That is the first part. And second part is about training. I'm saying the training, like such as software training. In this software training, you can say Python programming, then machine learning, deep learning, then different kinds of CAD/CAM software like ANSYS, which is used for the design and development of the different machineries and components in agriculture. And we can have different kinds of simulation based, analysis based software training. So this is related to the software training. Hardware related training, even in fact IoT tools, and then mechatronics related training. And the hardware related training now should say the drones which are we are going to operate, how to operate the drone by pendant, how to operate the drone by use of simulator, because the simulation software is going to operate by the student in the lab, and they can learn of how sensitizing these all operational tools which are going to make the easiness of those operations. And then automation in the drone operations. Then robotic operations, jackal, husky, cotton picking, or maybe the automatic guided vehicle, which are we have designed. So those things which we are designed, or maybe in due course of the training we can have a creation of the new model, which will be a attraction to the every one of those who are inspired to get training. So if they get some kind of output from their own hand in hands-on training, so they'll feel that they are really trained. If they are just formally coming and attending the training sessions by looking at screen, by looking at just listening at the speakers, it's just a, well, you are okay, we are okay, but it should not be okay unless and until you don't take it some physical outcome from the place. So that is the most important thing. So this is about the hardware training. And in fact those all GIS, GPS, ArcGIS, satellite remote based sensing, and the different kinds of the trainings that are being provided by IIT Kharagpur, IIT Bombay, and as now we are here in USA. So different United States universities like Washington State University, Pullman, they are now collaborate. We have a collaboration with them. Then University of Florida, where we are right now, we have collaboration with them. We are University of Polytechnic Valencia, then University of Putra, then AIT Bangkok, and so many universities. They are also trying to put their efforts in making webinars, then teaching them. And the most important attraction for all of you, that to say, we have a 1-year professional certificate course for 3 divisions as agri-boat, agri-drone, agri-AGV. However, the agri-drone, this new course we are going to start in the next month. So I like to just put this all information to the Just Agriculture portal links and the network.
Thank you, sir. Thank you for the information. Other question which I have got is that you have explained about the agri boats, agri drones, and how the agri drone agri robots are working in the field, like for the harvesting and grafting and harvesting of cotton also. So what is this technology available for farmers also, or it's in your institute only? Like, what about the transfer of technology?
Yeah, transfer of technology, we have a collaboration with rural craftsmen, then manufacturers from the different part of the nation, and also some foreign universities. Now you will get a new thing from us, that University of Florida is going to manufacture a drone with us, particularly the custom drones which are nowadays as required by the farmers. So these drones can be assembled and get available to those all farmers who are in need of the field operations for their own problems. So it can be customized. So professors from different universities will be a consultant, and they have their team, and they have the club where they are. I have a lot of videos to show you, but right now it is not having time. We have a special kitchen, which is in which we can have a lot of accessories get dumped down, and the students are taking those all materials and preparing their own drones, and then that is provided to the but it is going to be certified and get manufacturer's license, and once they get the license, and manufacturing startups can be initiated. So one can go for making entrepreneurship. That is very much good attraction in your workshop that I forgot to tell you. For agripreneurship, you have a this food printer which I have shown. One can take this part. Then drones that we are going to provide it by use of this collaboration, or maybe some of the drone manufacturers, they are coming to us for getting development of the new components for them. We will be making the new startups also to make the different gimbal production. So for agripreneur startups, that they are having a lot of opportunities to enter into this area. So in fact, the sensitized question, as you have mentioned, there is a robotic application certainly will not go to the Indian Farming Society, because it's a investment part which is going to be a worry, and which is going to be a you can say not justifying. The farmers need a sturdy stuff, that electronics device, mechatronics device, which will be just simplified to the use and its justification with the cost. So that we are going to make it by use of the smart portable machinery. So those smart portable machinery manufacturers can be provided. We have a bike moped manufacturer, in which the farmer can take the milk in the chill can system, which is developed in the bike, and that is working on the electronic based photovoltaic battery system based bike. So that can be available, because we have made and there are different manufacturers who takes the support from us and get their manufacturing done. So for those who are interested to have this kind of technology available, that we are going to share it soon by use of the portal information system. So it is available, no problem.
So the technologies which you have showed is patented by your institute, or like something
we are going to patent 3 to 4 devices, cotton picker machine, then which is we have specially attraction to, then the mobile operative sprayers, then drones that we are going to also, nowadays we are into that domain. So it will be also patenting. So this is kind of the new attraction, that maybe 4 or 5 devices, if we can launch them and make them perfect, because getting a launch, getting a patent is not important. Important is that how it can be reached to the maximum number of customers. If that is being used by the maximum number of customers, that itself is same as like your patent. In fact, the technology, knowledge that should be reached to the end user. So we are going to do that way. The technology will be also explored.
Okay, sir. And the question is, next question is about the 3D food printer.
Yeah.
So, sir, if somebody, if some aspiring entrepreneurs want to work on food processing in food processing industry and want to have or purchase that 3D food printer, then what is the procedure? Like they have to visit the website or something else? Like how they can purchase that or get that?
You mean to say 3D food printer?
Yes, sir. Like somebody is asking, like they just want to do something in this field, like as an agripreneur.
Oh, they want to become an agripreneur. Okay. So
Yes, sir.
if they want to become agripreneur, see, a lot of food industry production is going on, and one who search the new product is a kind of brainstorming, is a kind of own interest that we can support, and we can find them to strengthen their production. Like this Cibros brothers who came to us, and they started doing with their work. We have seen their keen attention towards this kind of a machine, and then we involved them to make the new design of the components in our CAD/CAM lab, and then 3D printing manufacturing. So like those all can be possible. And if they want to get the first thing is that becoming an entrepreneur, you should have a market survey of the different new components and their arrivals. As an electronics component market, you can have a $10 or maybe 800 rupees of component. The same component can be of 8,000. So it is market is in fluctuation. So those things which we are going to manufacture, maybe a 3D food printer or any kind of machinery, the component wise, those all things should get match up and make your product perfect. So for that, we are going to help you, those who are interested, definitely.
Sir, what somebody is asking, like, what is the estimated or cost of these tools which you have showed here?
Yeah, that's cost I have mentioned while my presentation. If you go for food printer, it will be around 80 to 90,000 approximately. If you add the facilities, because it works on your own mobile, that machine has to just feed mechanically. You have to feed just raw material, and once you feed that raw material, you need to just change the dyes which are coming out as extrusion. And then all operations, ladies sitting in the standing in the kitchen doing other operations. कोई अगर चाय बना रहा है उधर और उसी में ये मशीन चला के हमारा ये निकालना है, तो वहीं से वो मोबाइल से ऑपरेट कर सकती है. So that can be operated by use of mobile. Even somebody is out of home and wants to help at a home to get this machine run, can operate by use of the mobile. So the machine which runs in automation system, that may cost rise maybe more than 1 lakh also. If as on the facility adds, the model will add the version, and that will going to be increase the cost. Secondly, the sprayer machine, that is mobile operative, that is not much costlier. It can be up to 50,000 rupees to 70,000 rupees. You can have advance up to 60 to 80 liter of the pesticide tank I'm talking about. That is going to help the farmers in one stroke for at least 2 to 3 acres land होनी चाहिए उसमें, तो वो फायदेमंद रहेगा. और जो हमारा कॉटन पिकर मशीन है, that is also going to be a cost below 1 lakh rupees. So this is nearby 1 lakh rupees. You'll have these 3-4 kinds of devices which is available, and it will be modified to the good state of art.
Thank you, sir. And now we are done with the question, and it was a very insightful and very interactive session, I must say. And on the behalf of the participants, on the behalf of organizers and Team Just Agriculture, and on my personal behalf, I just want to thank you for such an insightful, such an informative session. Like we have got to know about various tools and technologies which your institutes have developed, and these are very informative, very commendable, I must say. And thank you, sir. Thank you for joining, and thank you for taking out your precious time for our training program.
You're welcome. And my
Thank you,
best
sir.
wishes
And
to all
thank you for always
participants.
supporting our
Wish
team
you a
in our
grand success.
endeavors. Thank you,
Thank
sir.
you. Thank you.
Thank you, sir. So participants, that's all for today. And now for more sessions, we'll join tomorrow and the link for tomorrow meeting will be shared in your respective WhatsApp groups. So thank you all and have a great evening.